Here we have my little wheel to work out surface speed of different things that I'm using in the workshop. I'm just going to do an experiment now in which I'm going to run through all the speeds in the lathe without changing belts, so it'll only be 6 speeds. And then I'm going to use the tachometer to tell me what the actual speeds are. And then I'm going to write down the calculated surface speed per minute working on the diameter of what this actually measures. I've as accurately measured as I can at 2.131 and 1/10 of an inch. And write those answers down, and then using my little surface wheel, use it on there, see what the results come up with and see how accurate it is, and then we'll go forward from there. It's going to be reasonably hard to show you what the tachometer is saying. The recall function on it isn't working, but what it does do, if you were to let go at some point, it will recall very quickly, briefly, the old setting before it resets, so we can see that. Okay, let's start off with 60. What is 60 in real life by the tachometer? You might even be able to see it a little bit, I don't know. Okay, so according to the tachometer, 73. 120. 's bouncing between 128 and 129. So we'll go 128. 200. 200. 224. 387, 388, 387, 388. I may have reset before even. Right, 600. 689 and 679. So I'm going to say 680. Rightio. 1050. 1185, 1184 it was bouncing. Right, 2.1311 diameter. You need to times that by pi to get the circumference. So it's travelling 6.6959 per RPM. Let's write that down. On the paper. This here surface is travelling at 6.6959 inches per RPM. So we've got 73 RPM. 488 inches, 0.8 inches. Let's divide that by 12 for feet. If the calculator didn't spin around. 40.73. feet a minute. 128 times our constant of 6.695 equals 857 inches a minute divided by 12. 71.44. .224 times our constant. Now we're up to 1500 inches a minute. So if we divide that by 12, equals 125.02 inches a minute. It's interesting to work out what speeds your lathe actually does, and the effect that the diameter has on your cutting. So that's why we make I'm making this little surface wheel, is instead of doing these calculations or guessing, you can sort of throw it on there, spin it up and go, oh, I want about 100 because I'm using high speed, etc. And you can say, yep, that's about right, we'll use that speed, or not. Okay, so the last one, 1050, which really was 1185, times our constant, which is how many inches per revolution it travels, is 7,936 inches in 1 minute. That's pretty fast when you think about it. Now you divide by 12. So if that was scooting across the floor at that speed, it'd travel 661 feet. 0.40 actually. In a minute. That's how far down the road it'd go. Right. Now, I need to test my little wheelie jiggy and see if you remember in the first video, I had a fudge factor of 2.5. Do you remember that? Right. So whatever the tachometer says, I have to times it or divide it. Then I've just got to double check. I think I divide it by 2.5. Now, how accurate is it going to be? I would be happy with it if it was in 5%. Let's see. So, change out our little tachometer Duvalaki, and this is a little bit tight. Oh, it is, especially if you miss the slot. Geez, my slot's bigger than the other one, and in the factory one I still missed it. Okay, so it's on. Rightio. So let's start at our slower speed. Rightio. So a little contact duvlaki. Of course, have to try and get the hands and everything out of the way. Not that you can really see what it's saying. Rightio, so that's telling me that's 600, well, whatever the, not 600. So that's telling me we're looking at 100, 101, 99, 100, 101. Okay, so let's go with 100. It should pop up. Alright, 100 briefly. So, if I was to divide that 100 by 2.5, ends up with an answer of 40 feet per minute. So we're not too far off. Had 40.73 actual. I'm just going to write it down, 40. Maybe put a circle around it. Okay, so our little surface duvad with our fudge factor of 2.5 is not too bad on that one. Oh, I've got a feeling it's going to get worse as the speed goes up, because you only need to be a percentage out per RPM, and it's just going to increase and get further out. When I originally made this, and I've used the micrometer to measure the diameter. This is the wrong one, but I'm just using it as an example. Bit of a joke amongst people is, oh, you've bought a whole heap of G-clamps for your workshop. Well, in this case, they do work as a little bit of a G-clamp, because it doesn't take a lot of force on this anvil to crush this O-ring. So you had to be really careful to try and get well, this is an unusual circumstance, using this as a tyre rather than an O-ring. So I had to sort of guess the best measurement. Now, hindsight, probably, maybe, with the accuracy not there within a caliper, if I'd used a caliper, maybe it would have been better. But because I did make it, so that's 15.36, 15.37. If I push and pull on that caliper, if I can hold it right, I can actually change that a good amount just by putting pressure on the caliper, because that is a spongy. So to get it perfectly correct was going to be pretty damn difficult. Particularly, I mean, you can even apply more or less pressure pushing this onto the, but you know, you've got to try and use some common sense. And as long as the wheel is spinning without slipping, just apply the least pressure that's required. It's the same with all tooling. I just don't like, or engines or anything, I just don't like flogging the guts out of them. Then you wonder why they don't last. Okay, I digress. Let's go back. Now we're up to, get it in gear. It was a bit rough after saying that. Right, 120, which is actually 128 according to the tachometer. Surface speed doodads saying 175, 176. Okay. So let's use 176. We're looking for an answer of about 71.4. So 176 divided by 2.5. Well, there we go. So we're 70.4. So we're about 1 foot per minute off. 1 foot off on the 120, 128. Why I'm doing this whole experiment, it does seem reasonably pointless, but what I'm hoping to see is, as I'm going down here, I'm hoping to see what are we going to say? It's almost like a ratio, or something is constantly, which I'm thinking it's going to be, constantly out. So I can alter my fudge factor to get it more accurate. So if 2.5 is not quite right, I might need to use a smaller fudge factor. It looks like it might need to be smaller because my division of 2.5 is producing a smaller number. So I might need to use 2.48. As long as you remember what the fudge factor is, it doesn't really matter. I mean, I could write it on here. When I've tested everything, I could write 2.48 or 2.47 or whatever it is. And so whatever this says, divided by that number, is your surface speed. It would be fantastic to have that dial up exactly right, but this is an RPM device. As I explained in the first video, I needed to get exactly the right O-ring. I ordered the wrong one. I can't be buggered looking for another one. I'm just going to wing it and do it like this. Yeah, it's a good way to play with some basic maths. Let's go to our fastest speed in this arrangement. 1185, this is going to be honking. Alright, 1610, 1612, 1615, 1617, 16, 18, 17, 18, 19, 20, 19, 18, 20. Okay, let's go with 19. It seems to be not the highest, not the lowest. 1619. 1619 divided by fudge factor of 2.5, 647.6. 647.6. So right at the end there, we were 61.4, 13.8 feet a minute off. Now that's not too bad when you consider we're doing 600 odd. But let me just have a bit of a look and see what is the actual factor that I should be using. Oh, there we go, 2.448. .448. 2.448. Let's do a middle speed, 350 RPM. What was that number? 500 or something? 533, 534. Let's go 533. So a new fudge factor of 2.448. 2.448. That's knowing where the camera is. It's not easy. Right. What was our fudge factor? Not our fudge factor. We're a 533 on our wheel divided by 2.448. It's 217.728, and our actual calculated actual would have been 217.12. So I reckon that's the magic number. I could even make that 2.48, 2.45. But if you want to be really accurate, as best with this setup I've got and machinery and whatever. 2.448 is the actual fudge factor. Not too bad considering I was running 2.5. I'm only what? 0.012 off. So I might just write that on the wheel. It's going to look a bit ugly, I know, but I'm going to forget it. And how I might write it is maybe a divide symbol. 2, 4, 2.448. So now I could be reasonably happy that any tool that I want to check the surface speed of, I can work it out with a calculator. I know it's not a direct read, but I've now made this a useful object.